In this lesson, we will discuss chapter number 3, integration exercise 3.3, question number 8, part B. And question we have integral of a square minus x square dx. So see, here we will substitute, suppose x is equal to a sine theta. So see, here a is the constant and this is the variable a sine theta. So again the question arises why I have taken sine theta. See, 1 minus cos square theta is equal to sine square theta. So this is the constant term, this is the constant term, and then second term, the variable is with the negative sign, variable is with the negative sign. So that is why a sine theta. Now we will take the derivative of it, dx y d theta, which is equal to a cos theta. Then we will do separate d theta, right? So dx, instead of now this dx, we can write down a cos theta d theta. We will put the values here, so it will be, see, a square will remains the same, which is constant. Instead of this x square, right, x is equal to a sine theta, which is equal to a square sine square theta. Instead of dx, we can put a cos theta d theta. Right, from the under root we can take a square as a common, remaining is 1 minus sine square theta a cos theta d theta. Right, so see, 1 minus sine square theta equal to cos square theta. So we can write down in under root a square cos square theta, and then instead of dx, same a cos theta d theta. So see, this square will cancel this square will cancel this. We have a cos theta d theta. Now see, we have two times a cos theta. So we have a square cos square theta d theta. Right, a square is constant, we can take outside the integral sign. We have cos square theta d theta left here. Right, so for cos square theta and sin square theta, we cannot do the direct integration. So what we will do, we will put the formula here, cos square theta, which is equal to 1 plus cos of 2 theta. See, double angle, and then you have to multiply with the constant term is 2, that is y2 d theta. Right, again this 2 is constant, so we can write down a square, which is already here, divided by 2, 1 plus cos of 2 theta d theta. Right, so 1 is separate plus cos 2 theta. Now we will do the integration separately. 1 d theta plus integral of cos 2 theta d theta. So for a square divided by 2, right, 1 d theta, which is theta, then plus cos of 2 theta equal to sine of 2 theta divided by this 2 constant plus c. Right, so this is not the answer actually. We have finished the integration, but this is not the answer. Why? Because see, here we have supposed that x is equal to a sine theta. We have to put the values again. Our question is in x, right? The variable is x. So here is sine of 2 theta. Here we have only sine theta. So we have to convert again this sine 2 theta into sine theta. So I will show you here how. It is equal to, I will write down again, a square divided by 2, and this is theta plus 2 sine theta cos theta divided by 2 plus c. So see this sine of 2 theta, right? This is equal to 2 sine theta cos theta divided by, we already had the 2 there. Now this 2 will cancel this 2. Whatever is there, a square divided by 2 theta plus sine theta cos theta plus c. Right, now we know the value that we have sine theta here. Sine theta is equal to x over a. Right, from here if I say I only need sine theta, so it will be x over a. But here see, we have cos theta as well. We have to convert this cos theta again into sine theta. How we will do this? So it is a square divided by 2 theta plus sine theta, and then instead of this cos theta we can write down 1 minus sine square theta. Why? See here, cos square theta is equal to 1 minus sine square theta. But here we have only cos theta. We do not have cos square. So we will take the square root on both sides. This will cross this. Only cos theta is equal to 1 minus sine square theta. That is why I have put here. Right. Now we will put the value of sine from here. See, sine theta is equal to x over a. Or if I want only theta, so theta is equal to sine inverse x over a. These two values we have to put here now. So it will be equal to a square divided by 2, instead of theta, sine inverse x over a plus x over a, and then this is 1 minus x square over a square plus c. This is fraction, we will take the LCM. So a square over 2 sine inverse x over a plus x over a, it will be a square minus x square divided by a square plus c. Right, in the next step, see, this is square, for the denominator will cancel this. So I will show you the result, which is equal to a square over 2 sine inverse x over a plus x over a. It will be a square minus x square over a, and then plus c 1. Now see, a square over 2 will multiply this and this both. So I will show you here a square over 2 sine inverse x over a. This will be again a square over 2 multiply x over a square into a square minus x square plus c. C or c1, whatever, only c is fine. So this a square will cancel this. What is remaining? A square over 2 sine inverse x over a plus x over 2 under root a square minus x square plus c. This is your answer. See, the question is lengthy, but you should know the formulas very well in order to solve the question. Right? Trigonometric formulas as well as derivatives you should know very well. Still, any point is not clear, without any hesitation, you can ask me, and thanks for watching.